Hello friends, today we are going to solve JAM 2022 max question paper. First we solve the first part. In the first question, look at the question. Consider the 2 by 2 matrix M is first row is 1 1, the second row is 1 0. Suppose if the 8th power of the matrix M satisfy the condition that is M power 8 into 1 0 equal to xy, then what is the values of x? So first you got to write the characteristic polynomial of the matrix. So clearly what is the characteristic polynomial? So p of x, so we can write p of x equal to x square minus trace of m. So here trace is 1, therefore minus x plus determinant, but here determinant is minus 1. So this is a characteristic polynomial. And we know that by Cayley-Hamilton theorem, characteristic polynomial kills the matrix, that is p of m is 0. So that is m square should be m plus identity matrix. So we need m power 8. So first we find m power 4. So m power 4 is nothing but m square into m square. So that is nothing but m plus I whole square is nothing but m square plus 2 times m plus I square is nothing but I. Since we know that m square is nothing but m plus I, so you have to substitute here m square is nothing but m plus I, therefore m plus I, and here we have 2m plus I. So totally we have 3m plus 2y. So this is m power 4. So we need m power 8. So we have to multiply this m power 4 2 times, therefore m power 4 into m power 4 is nothing but m power 8 is 3 times m plus 2I into 3 plus m plus 2I is nothing but whole square. Okay, we have to multiply 2 times. So this is nothing but 9m square plus 2 this 2ab. So therefore 6, and then we have 12 times m plus 4 times I. Again you have to substitute m square equal to m plus I. So you will get 9 times m. Okay, we can directly write 9m plus 9I. Okay, so 9m plus 9I plus 12m plus 4I. So if you add this one, we get 21m, 21 times m, and then this 9 plus 4 is 13 times I. So therefore we get m power 8 is 21m. So 21 times what is m? 1110 plus 13 times identity matrix, that is 1001. So if you multiply and then sum, we get 21 0 plus 13 0 0 13. So if you sum, you will get 34, and here 21, and here 21, here 30. So this is m power 8. The matrix m power 8 is this one. But this m power 8 satisfies this condition. If you multiply with this vector 1 0, suppose if you multiply with the vector 1 0, you will get one vector. So what you will get? 34 into 1 is 34 plus 21 times 0 is 0. And then 21 times 1 is 21 plus 13 into 0 is 0. So this is a vector. They are asking the first vector, first position coordinate. Therefore 34 is the correct answer. Therefore answer is 34. Okay. Now look at the second question. The rank of the 4 by 6 matrix. So we have to find the rank of this matrix. So the simple way is you have to apply the elementary row operation on this matrix. You finally get a row reduced echelon form. So a row reduced echelon matrix, the first non-zero entry of each row should be 1. The corresponding column should be 0. So therefore, we have to look at this one. This is the first column, first row. Now we find the first non-zero entry is 1. We have to make this entry 0. So therefore, we have to subtract the first row minus second row. You'll get this one. Therefore, keep the first row 1 1 1 0 0 0, and if you subtract, you'll get first row minus or second row minus first row. You can take 0, and otherwise you can, okay, anyway, you can just subtract. So this is minus 1, this is minus 1, and this is 1 1 0. So what we are doing here, the second row is nothing but r2 minus r1. We have to replace the second row by, we have to subtract second row minus first row. You will get this one. Okay, now keep the third row 0 1 0 1 0 1. The fourth row also you have to keep 0 0 1 0 1 1. Now scan the first row. You will get a non-zero entry here. The corresponding columns are 0. Okay, now we did the first step. Now look at the scan the second row. Now look at scan the second row. The first non-zero entry should be here minus 1, but we need a plus 1. Therefore, you have to multiply minus in the entire row. But you have a non-zero entries to this entry. You have to make these two entries as 0. Okay. So better you have to multiply minus 1 to the second row. So directly I can write. So therefore, this is plus 1, and this is plus 1, and this is minus, and this is minus. Okay. So now maybe I can erase this. So this should be plus 1, and this should be minus 1. Now we have to make this entry and this entry should become 0. Therefore, we have to subtract uh, first equation R1 minus R2. So therefore, the next you have to keep the, but we have to change the first row R1 by R1 minus R2. Therefore, the first entry 1 minus 0 is 1, but 1 minus 1 is 0, and here 1 minus 1 is 0, and this should be plus 1, this should be plus 1, and this is 0. Now keep the second row. Now third row again, we have to subtract the third row is nothing but R3 minus R2. So therefore 0 minus 0 0, 1 minus 1 is 0, this is minus 1, and this is 2, and this one is plus 1, and this one is 1. Now keep the third row, sorry, fourth row. Now if you scan the second row, you will get the first non-zero entry is 1, and then the corresponding other terms are 0. Okay, now look at the scan the third row. If you scan the third row, you get the first non-zero entry in the third column, because should be echelon matrix. So here we the first non-zero entry you get the first column, and the second non-zero entry in the second row will get in the second column. Therefore, here should be get in the third position, third column. But here we have a minus 1. Therefore, again we have to multiply minus the entire third row. Therefore, I can directly this is plus 1, and this is minus 2, minus 1, minus 1. Okay, so what I am doing here, so we have to multiply R2 by, sorry, R3 by minus R3. We have to multiply minus. Now we have to make this entry, and this entry should become 0. We have to make these two entries are 0. So we have to subtract R2 minus R3. So keep the first row. In the second row, we have to subtract. So that is R2 is nothing. We have to change it by R2 minus R3. So therefore 0 minus 0 0, 1 minus 0 is 1, and then 1 minus 1 is 0, and then minus 1 minus 2 minus plus 2, therefore we get 1, and then here we get 0, and here we get plus 1. Then you have to keep the third row 0 0 1 minus 2 minus 1 minus 1. and then you have to make keep the last 0 0, but anyway we have to make the this entries also we have to make 0, right? Therefore again you have to subtract r2 r3 minus r4 or r4 minus r2. Therefore the fourth row we have to replace by r4 minus r3. Therefore 0 minus 0 0, 0 minus 1 is 0, 1 minus 1 is 0, and this we get 2 here, and then here we have again 2, and then here also we have 2. Now if you scan the third row, we get the first non-zero entry here, and then the corresponding all the columns entries are 0. Okay, we did then the third row. Now if we scan the fourth row, we get the first non-zero entry here, but this is not equal to 1. Okay, so we have to make this entry is equal to, therefore if you multiply 1 by 2, you get every entry is 1, right? So therefore we have to multiply 1 by 2, therefore we get 1 1 1. So again we have to make this entries are 0. Okay, anyway this we can easily find that this you can easily make that this entries are 0. Therefore how many non-zero rows? We have 4 non-zero rows. This is our non-zero row, this is also non-zero row, this is also non-zero row. So totally we have a 4 non-zero rows. Therefore rank of the matrix should be 4. Okay, the number of non-zero rows in the row reduced echelon form is the rank of the matrix. Okay, otherwise you can find the kernel of the matrix, and then use the row rank nullity theorem. You can find that rank is 4. The nullity should be 2. Okay, now the next question: let V be the vector space of all polynomials in one variable with a real coefficient of degree at the most 6 together with 0 polynomial. Then which of the following is true? And look at the first option, set of all polynomials with the condition that if you evaluate this polynomial at the point 1 by 2, it said that it does not belongs to Q, is a subspace or not. Clearly the 0 polynomial not satisfy this condition. Okay, because 0 polynomial at any point you'll get always 0. Okay, so therefore 0 is not in the subset, therefore it's not a subspace. Again clearly look at the second one is also not a subspace. Again the 0 polynomial not satisfied at the condition, because 0 of at 1 by 2 is always 0, but you will not get to 1 always. Again similarly we can find this one. Okay, derivative of the 0 polynomial is also 0. Again this is not a subspace, but we can easily prove that C is a subspace. And look at the third option is always a subspace. So how to prove this is a subspace? Again we can take two thing, maybe we can call this is some W. Suppose if you take two polynomial fm f comma g in the W, so therefore this both f and g satisfy the condition f of 1 by 2 equal to f of 1, and g of 1 by 2 equal to g of these two polynomial satisfy this condition. Now what we have to prove? We have to prove that the sum should be in this collection. That is, the sum at the point 1 by 2, we have to prove that this is equal to f plus g at point 1. So this is nothing but the addition is defined pointwise, f of 1 by 2 plus g of 1 by 2. But we know that f of 1 by 2 is nothing but f of 1, and g of 1 by 2 is nothing but g of 1. Again by addition, we can rewrite this f plus g at a point 1. So therefore the sum satisfies this condition. Therefore sum f plus g should be in the collection W. Next we have to prove that the scalar multiplication. So if we take some alpha in R, a real number, and then if we take f in the collection W, we have to prove that alpha times f at a point 1 by 2, we have to prove this is equal to alpha times f at a point 1. But how we define the scalar multiplication here? Alpha times f of 1 by 2. But f of 1 by 2 same as f of 1, because we take f from W. And by the definition, this is nothing but alpha of f at a point 1. Therefore, alpha f belongs to this collection W. Therefore, clearly this W is the subspace. All others are not a subspace because the 0 polynomial is not in the collection. Okay. Now come to the fourth question. So let G be a group of order 2022 and H and K be a subgroups of G of order 337 and 674 respectively. So it's given that the cardinality of G is 2022 and the cardinality of H is 337. Cardinality of K is 674. And it's given that the union of these two subgroups are subgroup. But usually in general, the union of two subgroup need not be subgroup. When the union of two subgroup, one is contained in other. Therefore, either H is a subset of K or K is a subset of H. But H is the cardinality of H is very small, right? Therefore, so since it is given that H union K is a subgroup, therefore this H should contain in K. K cannot be contained in H because K is cardinality is higher than cardinality of H. Therefore, H should be a subgroup of K. And we know that what is the cardinality of this K by H? If you look at the quotient group uh, K by H, so what is the cardinality of this is actually 2 because 674 by 337, if we cancel we get 2. So therefore index of K in H is 2 by theorem implies that this subgroup H is a normal subgroup in K. Therefore H is normal. H is normal in K. So now we can easily eliminate the question. So look at the thing. Uh, so they're asking which of the following is false. So the false one is B is the false one because they say that the order of H union K is 1011. So but what is H union K? Because we know that H is a subset of K. We know that. So the implies what is the union? Union should be K. Therefore, cardinality of H union K should be cardinality of K. But cardinality of K is 674. Therefore, that statement is the wrong statement. And then the order of H union K is third one is correct because we just now we proved that this order union order is 674. And then H is a normal subgroup of this one. Okay, because actually this nothing but actually K. Any group is itself is a normal subgroup, right? Therefore, K is a normal subgroup of K. That is true. Now, this is nothing but actually K. Just now we proved that H union K is nothing but K. Therefore, and then we proved that H is a normal subgroup of K. Therefore, option A is correct. Option D is also correct. Option C also correct because H union K is nothing but just K. Therefore, the wrong option is the wrong statement is the B because this is nothing but K. But we know that order of K is 674. Therefore, the second option is the false one. Okay. Now go to the next problem. The radius of convergence of the power series, this one. So we have to take this an, all the terms you have to take an and then take power 1 by n. So therefore n power 3 by 4 power n into x power 5n power 1 by n. So this is equal to if we will get n power 3 by n and then we can cancel n, we have x power 5 by 4 power n by n is cancelled, we get n. Okay, now as n goes to infinity, anyway this goes to this, anyway this n power 1 by n converges, therefore we get x power 5 by 4. Okay, so therefore the power series converges, the series converges, the value should be less than 1. Therefore x power 5 should be less than 4. Therefore x should be less than fifth square root of 4. So therefore answer is B. Okay, therefore the radius of convergence should be 4 power 1 by 5. Okay. Now look at the sixth question. Let x and yn be a real sequence defined by x1 equal to 1, y1 equal to 1 by 2, and then xn plus 1 is nothing but average between this xn and yn, and this yn plus 1 is nothing but square root of xn yn. And this is very simple. We know that the relation between the algebraic multiplicity and geometric arithmetic. So the geometric arithmetic less than or equal to the algebraic multiplicity arithmetic. So at GM is less than or equal to AM, right? So square root of AB less than or equal to A plus B by 2 for any AB positive. For any AB positive, this is always true. Therefore, this is nothing but yn plus 1 less than or equal to, this is nothing but xn plus 1. Because I am taking here all us are positive number. All the x's are fk's are positive, all yns are positive. Therefore, each x and yn satisfies the condition. Okay. So actually, simply I am saying so each xn and yns are positive number. Okay, each xn's are strictly positive and yns are also strictly positive. Then this xn and y, this for any n, this xn and yn satisfy the condition. Square root of xn into yn is always less than or equal to the average. This is true for every n. So this is nothing but actually yn plus 1. This is less than or equal to, this is nothing but xn plus 1. Therefore, this yn sequence, so this is true for every n. Okay, so directly we can write, simply we can write for general n yn, because y1 is less than or equal to x1. Okay, so therefore in general yn is less than or equal to xn for all n. So therefore the sequence yn is always bounded above by the sequence x1, okay, or xn's. So if you mark the points, you can look at that these yns are increasing, these xn's are decreasing actually. Okay, so and we know that any bounded above sequence converges, any bounded below sequence is converges. So from this we can conclude that the sequence yn is bounded above. Always bounded is bounded above sequence. Okay, and then xn is bounded below sequence, and it also is increasing actually. So even this yn is increasing, xn is decreasing. Okay, bounded below. So also this yn is increasing. Okay, this yn is increasing sequence, this xn is decreasing sequence. Okay, and we know that any increasing sequence bounded above sequence is convergent. Again, similarly, any decreasing sequence bounded below is convergent. Therefore, both the xn and yn is convergent sequence. Okay, now we can eliminate the option A and B. Okay, because both the sequence should be convergent. Now we have to say that what about the limit of these two sequences? Yeah, both are equal or strictly less. Okay, suppose we know that both are convergence, both xn and yn is convergent. Look at this one. Suppose this sequence, the right hand side xn plus 1 is a subsequence of xn. Therefore, suppose assume that xn is converges. Therefore, assume that xn is converges to x, and yn also converges. Therefore, assume that yn converges to y. Okay. So if look at this in identity, xn plus 1 is a subsequence of xn. Therefore, that also converges to x, and this equal to this xn converges to x and yn converges to, therefore xn plus yn converges to x plus y by 2. So if we simplify this, what will get? 2x equal to x plus y. Therefore we can cancel 1x, we get x equal to y. Therefore both the limits should be equal. Even if we take this identity, so again this is converges to y equal to square root of xy. So anyway these are all positive, therefore y square should be x into y. Y is non-zero number, because everything is non-zero, we can cancel one y, we get x equal to y. So anyway, both the case the limits are always equal. Therefore the option is both xn and yn is convergent, and the limit of xn and the limit of yn should be equal. Okay. Now look at the seventh problem. Suppose if we consider these two sequence, look at the first sequence an equal to this. So we have to looking about the convergence. Suppose if we find that an plus 1 by an. So what is this? It's 3 power n plus 1 minus 3 by 5 power n plus 1 minus 5. This is actually plus 3. So this is an. By an plus 1, therefore should be we get 5 power n minus 5 by 3 power n plus 3. So this is an plus 1 by an. So we can take 3 power n plus 1 outside from the first term. We get 1 plus 1 by 3 power n. If we take 5 power n outside, we get 1 minus 5 by 5 power n minus 1 divided by, again if we take 5 power n plus 1 outside, we get 1 minus 1 by 5 power n. And if we take 3 power n outside, we get 1 plus 1 by 3 power n minus 1. So we can cancel 5 power n and then 1 5 power n and then 3 power n 3 power n cancel. We go in the numerator, we have 3. As n goes to, anyway, we can write 3 times 1 plus 1 by 3 power n into 1 minus 1 by 5 power n minus 1 by 5 times 1 minus 1 by 5 power n into 1 plus 1 by 3 power n minus 1. As n goes to infinity, this term goes to 1. Anyway, this term goes to 0. Therefore, this term goes to 1. And then this goes to 0. And this goes to 0. And this goes to 0. As n goes to infinity, everything goes to 1. Therefore, we get 3 by 5. Therefore, the limit n goes to infinity, modulus of an, anyway, everything is positive number. If you want, you can take the modulus. Modulus of an plus 1 by an is nothing but 3 by 5. So the 3 by 5 value is less than 1. And we know the result that therefore this should be convergent. Therefore sequence an is convergent. Sorry, the series an is convergent. Okay. Now what about the sequence series bn? Okay. So the bn should be divergent. So why the bn should be divergent? So we have to use the result. Okay, what is the result we are going to use? Suppose we have two sequence an and bn, and the limit n goes to infinity an by bn is non-zero number, then both an and bn have a same behavior. If an is convergent, then bn is convergent. If an is divergent, then bn is also divergent. Okay, so we are going to use that result. So we have to choose some cn is, I'm going to choose 1 by root 2. Sorry, 1 by root n. Clearly, this is nothing but summation Cn is divergent because n power 1 by 2. So n power 1 by 2, this 1 by 2 is less than 1, therefore the series is divergent. Okay. Now we have to find what is this Cn by b. Okay. So what is always bn by Cn? The sequence Cn bn by Cn. Bn is nothing but 1 by 1 plus n square power 1 by 4 into Cn, but Cn is nothing but you can take a root n. Okay. So now if you take the n square outside from the denominator, so therefore we get root n by, if you take n square outside, therefore n square power 1 by 4 plus into 1 plus 1 by n square power 1 by 4. Okay. Okay, otherwise, yeah, so this is nothing but n power 1 by 2. This root n and root n is cancelled. Okay, this is actually root n. This root n and root n cancel. As n goes to infinity, this goes to 1. Anyway, it's a non-zero number. Okay, so therefore we know we get that limit n goes to infinity. This the quotient bn by cn is some l. This l is some non-zero number. Therefore, both bn and cn, the series, have same behavior, and we know that summation cn. What is summation cn? Summation 1 by square root of n. So we know that this is divergent, and the theorem says this both series bn and series cn have the same behavior. Cn is divergent, therefore bn is divergent. Therefore, the correct option is summation an is convergent and the series bn is divergent. Okay, so option C is the correct answer. Now, the same thing for this problem. We have to choose another sequence an such that the quotient should be non-zero number. Okay. Suppose we take the given sequence is an. So an is given nth term, that is okay. The only this term 1 plus 1 by n power p. Okay. So we have to take this is our n. Now we can choose bn is 1 by n power m. Okay. Now find bn by an, the quotient. You'll get 1 by n power m. Okay, sorry. Yeah, I can take. So an is 1 by t, right? Therefore, you can take 1 plus 1 by n power t. Okay, sorry, I can take n power m, because our sequence is original nth term is n power, right? So if we take this one, so you'll get this n power m. So we can cancel this n power m. Now as n goes to infinity, this goes to 1. This is a non-zero number. Therefore both an and bn have the same behavior. And look at this summation bn. When this series, when the series is convergent, only when this m is strictly greater than 1. Therefore summation 1 by n power m, because we say that is the given series should be convergent. Therefore since an is convergent, therefore automatically the summation bn is convergent. And we know that when this convergent, only when m should be greater than, okay, strictly greater than. Therefore in all the case we have m strictly greater than 1 in the first option. Therefore option A is the correct. Now the next one is actually this is a wave equation. If you study in the differential equation, the solution of the wave equation, okay, that is called the d elements principle. Okay, so the general solution is u of x comma t equal to f 1 by 2 times f of x plus ct plus f of x minus ct plus 1 by 2 times integral x minus ct to x plus ct g of t into dt. Okay, where this u is actually u of x comma 0 at the initial condition is nothing but you'll get f of x, and then at the time if you take the derivative and then the initial time you will get g of x. Okay, so the condition should be the first two. So actually this is a solution of wave equation. So this is a wave, one dimensional wave equation. Okay, here f is 0, therefore we get, and g is nothing but this e power, they use some other variable s, but this is g. Okay, so this is actually solution of wave equation in one dimensional case. Okay, therefore option A is the correct answer. Okay, so the next final one, the last question of this part. Suppose u equal to this and v equal to this. Okay, and then what is the value of this Jacobian? Actually this determinant is nothing but Jacobian of these two functions. We have to differentiate u partially with respect to x, and then you have to differentiate u partially with respect to y, and then you have to take the determinant. Actually this is nothing but usually they use the notation Jacobian of u comma v. So this is nothing but sometimes use dou uv by dou x xy. Okay, this is another notation to denote this determinant. But anyway, so we can directly find what is ux, uy, vx, vy. Okay, partial derivatives. So first you have to differentiate u partially with respect to x. You'll get apply the derivative of x is 1. Okay, so therefore 1 minus, we have to apply here u by v, because numerator and denominator both have functions of x. Therefore x square plus y square whole square, and then you have to fix the denominator and then differentiate numerator with respect to x. Therefore we get 1. Okay, and then minus, you have to fix the numerator and then differentiate the denominator x square plus y square with respect to x. We get only 2x. Okay, so what you'll get 1 minus, Actually this is x square, this is minus 2x square, therefore we get y square minus x square by x square plus y square whole square. So if you want, you can take minus outside, we get 1 plus x square minus y square by x square plus y square whole square. So this is ux. So what is uy? Partial derivatives of u with respect to y. So in the first term there is no is independent of y, therefore 0. So therefore minus, you have to apply u by v method again. So therefore x square plus y square whole square, and then you have fixed the denominator x square into y square. If you differentiate the numerator with since the numerator is x, if you differentiate partially with respect to y, we get 0 minus, you fix the numerator and then differentiate x square plus y square, we get 2y. So therefore minus minus plus, we get 2xy by x square plus y square whole square. So this is ux. So similarly you can find vx. So I'm directly right. So vx, you'll get the same thing. Okay. And then vy is nothing but we will get a minus of this vx. Okay. So maybe I can directly write the identity. So this vx and uy, sorry, minus vx and then uy should be equal, and then what is ux is same as vy. Similarly, if you find again ux and vy, you will get this one. Okay. So now what is the determinant? So actually this is the determinant of ux, uy, vx, vy. So that what is the determinant? Ux vy minus uy vx. So this is the determinant. So therefore the determinant equal to ux vy minus uy vx. But using this identity, so this vy is nothing but ux, therefore ux into ux square, and then this vx is nothing but minus uy, therefore minus minus plus uy square. Okay, so this is the determinant. Now substitute the value. We know that what is ux and what is vy. Okay, so and then we have to evaluate at the point cos theta comma sin theta. So this is x and this is y. Therefore, in that all the denominator, look at this. This is actually our ux, and this is our uy. You have to square these two terms and then you have to sum at the point x equal to cos theta, y equal to sin theta. In the denominator, we have x square plus y square. Therefore, cos square theta plus sin square theta is always 1. So, therefore, we have directly I can write, and we get only 1 plus x square minus y square whole square. There is a ux. So I eliminate this x square plus y square, because if substitute x equal to cos theta, y equal to sin square, the denominator is we get 1. So we get 2xy. So finally we get 1. So and then substitute x equal to cos theta, y equal to sin theta now. So therefore 1 plus cos square theta minus sin square theta whole square plus 2 times cos theta into sin theta. Okay. So this is nothing but, so we can easily know that this cos square theta plus sin square theta is nothing but cos 2 theta. Therefore 1 plus cos 2 theta whole square plus 2 cos theta sin theta is nothing but sin 2 theta. Okay. Now if we expand this 1 plus 2ab 2 cos 2 theta plus cos square 2 theta, and this should be sine, oh we have square here, I missed the square. Okay, because we have to square it. So therefore sine 2 theta square, therefore sine square theta, sine square 2 theta. Therefore sine square theta plus cos square theta is 1. 1 plus 1 is 2. We can take 2 outside. We have 1 plus cos 2 theta. And 1 plus cos 2 theta is nothing but 2 times cos square theta. Therefore 2 into 2, 4. Therefore 4 cos square theta. So this is the determinant of this one. Therefore option 4 is the correct. So, so this is the first part of this jam question paper. Everything is a 1 mark question. So the next video we will discuss about the second part. Okay, thank you.